Good morning, Erase. Today is the 17th of May, 2020. We are now in week 7. So today's lesson 1 and 4. So we're going to move on to a new topic, Pythagoras Theorem, which is quite a fun, enjoyable topic. So hopefully you'll enjoy it as much as I will. So we're just, it's all about right angle triangles, okay? So Pythagoras Theorem relates the length of what's called the hypotenuse of a right angle triangle to the length of the other two sides. And we'll see a bit more of this in a second. And what we learn is that the hypotenuse is always the longest side. It is always the side opposite the right angle. Okay, so if you just bear with me once again, I'm just going to open up the PowerPoint. So, introducing Pythagoras Theorem. So, as I said, it's all to do with right angle triangles. So, it's triangles that have a 90-degree here in the corner. So, right angle triangle contains a right angle. And the longest side, so if I was to measure the sides of this triangle, then I would always find that the longest side is called the hypotenuse. So, it has its own special name, and the way to pronounce is hypotenuse. Okay? So let's have a look at which side is the hypotenuse. So remember, the hypotenuse, the longest side, is always the right, opposite the right angle, and it is the longest side. So if you were to look at this diagram, so you've got side C, side A, and side B. Which side is the hypotenuse? Is it side C, side A, or side B? Okay. Now, as I said, because it's the side opposite, and it's almost made clear to you, but here you can see that this is a right angle, even though it looks a bit, slanted. So you would say it's side B. What about this one? Which side is the hypotenuse? So is it side A, side C, or side B? So which side do you think is opposite? Is there a right angle here? Is it opposite this side? Is it opposite this side, or is it opposite this side? Here we can say there's another right angle, so we can say it's side B. How about this one? Would it be side B? So is it opposite a right angle? Is side A and opposite a right angle? Or is it side C and opposite a right angle? You can see from here it's side C. What about this triangle? So again, we've got side C, and side B, which is say is opposite. So side B is opposite to the right angle, or is it side A opposite the right angle, or is it side C opposite the right angle, and it's side C. And we'll have a look at one more. So would it be opposite side C, opposite side B, or opposite side A? What side do you think is the hypotenuse, the longest side? A, B, or C? C. And we'll move on from this. I think we've done enough. You've got the idea now, yes? So the history of Pythagoras' theorem. Now, got to understand that although we, in the history of maths, we say that the ancient Greek mathematicians discovered this idea that the two sides of a right angle triangle is equal in length to the longest side, the hypotenuse squared. Is, other ancient civilizations have, discovered this theorem for themselves. But because of the history in Western civilization, Europe, where a lot of ancient maths was attributed, given recognition to Greek mathematicians, as the ancient Babylonians, Arabs, civilizations, Chinese, Indian, and Safavids of Iran, they all independently discovered this theorem themselves as well. So it's not just the Greeks, other ancient civilizations, even before the Greeks, actually discovered this theorem. There's actually some tablets that were discovered in Iraq, which were from 3000 BC, where you can see on this clay papyrus leaves, where you had some old school questions that young children were doing back then to do with Pythagoras. So, but it's named after the Greek mathematician Pythagoras. So Pythagoras' theorem concerns the relationship between the sides of a right-angled triangle. The theorem is named after the Greek mathematician and philosopher Pythagoras of Samos. So, as I said, although this theorem is named after Pythagoras, the result was known to many ancient civilizations, including the Babylonians, Egyptians, and Chinese, at least 1,000 years before Pythagoras was born. Okay? So what Pythagoras' theorem, so this is a theory, what it says that the square formed of the hypotenuse of a right-angled triangle. So if I have this, if I know, say this side is 3 centimeters, then these sides are all the same length, are all 3 centimeters, has the same area as the sum of the squares formed on the two other sides. So this square, which again will be equal in length, all 4 sides the same, to this length, plus the area of the blue square. So again, the length of the blue square will be the same as the length of this side. So the red square plus the blue square will be equal to the area of the green square. Okay, we'll come back to these in a minute. I just want to go back to questions in our book. So as I said, the Pythagoras' theorem states that for any right-angled triangle, now remember, this only works for right-angled triangles, not any old triangle. It has to be a right-angled triangle. So we're saying the square of a hypotenuse is equal to the sum of the squares on the 2 shorter sides. So as I showed you before, with the blue square and the red square is equal to the green square. So now if we illustrate this, so if we use the letters A, B, and C, so the theorem basically states that the length of A squared plus the length of B squared is equal to the length of C squared. So saying A plus B is equal to the length of C, where C is the length of the hypotenuse. So if we look at this example, so it says verify, check that Pythagoras' theorem for the right-angled triangle opposite. So here we have the right-angled triangle. So let's call this side A, this is side B, and this is side C. Now this side C is our hypotenuse, which we write as HYP for short. Now we know this is a hypotenuse because it's the side opposite the right angle. So what we're saying is that this side here, 9 plus 40 is equal to 41. Now if you're thinking, hang on a minute, 9 plus 40 does not equal 41, but remember, it's a square. So if I show you the solution, okay, so here, as I said, A is 9, B is 40, and C is 41. So the theory is A squared plus B squared is equal to C squared. Okay, so A squared, 9 squared is 81. B squared is 40 squared, which is 1,600. So the A squared plus the B squared, 1,681. And the C squared, the 41 squared, is 1,681. So for this triangle, using Pythagoras' theorem, we can most definitely say that this side squared plus this side squared is equal to this side squared. Okay, so here we can prove that A squared plus B squared is equal to C squared. Okay, this actually is also used as a proof without measuring and without using a protractor to measure the angles, that this indeed is a right angle triangle. So if this wasn't a right angle triangle, Pythagoras' theorem wouldn't work. Pythagoras' theorem only works if a triangle is a right angle triangle. So if you did the calculation, you found that this side squared plus this side squared does not equal this side squared, then it is not a right angle triangle. No matter how how good it looks, it's not the case. So for today, I'm going to ask you to, you don't have to copy the diagrams, you can sketch them if you want. First of all, which side is a hypotenuse in each of the following triangles? So again, remember the hypotenuse is it this side or this side or this side? And it's always, remember, it's the longest side, even though we can't measure it. We don't need to measure it. You might think, is it this side or this side? It's always this side opposite the right angle. So we're saying this side here, side PQ is our hypotenuse. So I'll let you guys do question B, C, and D. Okay, so we say PQ, the side PQ is where the hypotenuse is. So can you do that for today? So you're going to do question part B, C, D, so identify where the hypotenuse is. And then for each of the three diagrams on the next page, calculate the area of square A, calculate the area of square B, calculate the sum of the area A and B. So that means add A plus B and calculate the area of C. So that was like the example we saw before, that how to work, prove Pythagoras Theorem, saying A squared plus B squared is equal to C squared. So I've got the questions here again in case you need to refer to it. So for this question, this side here is 13, this side here is 5, and this side is 12. So the area of A, okay, so you would work out 5 squared. Area of square B, now remember the area is the length times the width, but because it's a square, the sides are the same, so you just simply do 12 squared. So you're going to work out 5 squared, which is 25. 12 squared is 144. So you're going to do 25 plus the 144 is equal to 13 squared, basically. So area of A plus area of B is equal to area of C, 13 squared. Use the calculators, do the work, show me your answer. And then so remember there was 3 diagrams. So this one was for diagram 1. Diagram 2, again, you do the same. So work out the area of square A, 8 squared, plus the area of B, 15 squared, is 8 squared, plus 15 squared is equal to 17 squared. Check. And with the third diagram, you've got square A is 11 centimeters here, so 11 squared plus 60 squared is equal to 61 squared. Okay, fairly straightforward questions. Hopefully you shouldn't find this too difficult. And moving on, so the next part is verify. So check that the right angle. So here we're saying, is this really a right angle triangle, or is it a very badly or very good but not accurately drawn right angle triangle? Although it might look like it, we can prove that it is or not by using Pythagoras Theorem. Because we know that this side squared plus this side squared will be equal to the length of the hypotenuse squared. So using this example, can you verify? Can you check, prove that these are right angle triangles? So although you might look at this and think, well, I can see the right angle there, therefore it must be a right angle. No, you've got to use Pythagoras now to actually check, verify that these are proper right angle triangles. So you're going to do that, but like we did with the previous, you're going to say, okay, 10 squared plus 24 squared is equal to 26 squared? So you're going to 10 squared plus 24 squared is equal to 26 squared. If it is, it's a right angle triangle. If it is not, then it is not a right angle triangle. So I'll let you do question B and C. Again, use your calculators to check this out. So let me just write this out again a bit more better. That's 10 squared. Okay, Then for question 4, so the whole numbers 3, 4, and 5 are called Pythagorean triple because 3 squared plus 4 squared is equal to 5 squared. So triangle length of 3, 4, and 5 is centimeters is right angled. And there are more Pythagorean triples, not this one. So the triple, is 3. So here we've got 3 numbers, 3 plus 4 plus, the 3 and the 4 and the 5 satisfy Pythagoras theorem. And there are other sets of Pythagorean triples, and you're going to find out what they are by checking this 15 squared plus 20 squared is equal to 25 squared. So 3 numbers, do they work like this example here? Are they a Pythagorean triple or just random numbers that look like Pythagorean triples? Okay, that's the objective. And that's the lesson for today. So you've got 4 questions. Remember to write out the questions, show your workings, and use your calculator to work these out. If you have any issues, message me and I'll send you a link for Zoom and I'll help you through the questions. But hopefully these questions should be quite straightforward. And then tomorrow we'll move on to working out, the calculating the length of the hypotenuse. So enjoy your day. Hope all is well, and let me know if you have any questions. Other than that, enjoy your day, and I look forward to seeing you guys tomorrow.